Guys, I'll start off by graphing these. They're actually very easy. You need a pencil though because there's a lot of erasing going on. But basically a piecewise function is just that. You take all these functions and you graph little pieces of them. That's it, okay? So it's not anything too major. So if we want to talk about this one, I want to graph 2x minus 3. But I'm only going to graph as long as x is less than or equal to 0. So let's think about this. This is x, right? So I'm only going to graph this side because I want x to be less than 0. Does that make sense? Now, so what you can do if you want, if you're going to graph this, it's a line, so you start at 3. Okay, and then my slope is up 2 over 1. Okay, so here's the line that you actually have. Right? And I know it's kind of hard to see because of the pencil, because of my pencil. But it tells me I only want x to be less than or equal to 0. So what I tell my kids to do to make this easy, put your pencil on x equals 0. Here's x equals 0, right? I want everything to be the left of that is true, right? Everything less than 0. So everything to the right of my pencil, you would erase. You'll get so good at this that you just won't even graph that anymore, and you won't even need to erase it. But so this is the part of the line that you actually have. Now let's go to the next one. Okay, this one says, look at my restrictions. X is greater than 0. So I'm going to put my pencil on x equals 0 to kind of get an idea. And so I'm going to graph this line, but I'm only going to graph the part that's on the right side now, right? Because these are the x-axis. These are x values bigger than 0 over here. So I'm allowed over here. So if I graph this line at -1, bless you. I'm at -1. Okay, which is down here. But I'm not allowed to be here because am I allowed to be equal to 0?
Nope.
No, it just said greater than 0. So this at -1 needs to be an open circle. It's a piecewise function. It's only going to be true in one or the other, not both. Okay? So now then, I have a slope of -1. So down 1 to the right, and so forth. Okay, now it does look strange, right? But remember talking about functions forever ago? And what is the rule? You can visually look at something and tell if it's a function. And what does it have to pass? Something called the what? The vertical line test, right? So I should be able to put a vertical line anywhere on this picture. And how many things am I allowed to actually touch? 1. Well, the only place that there might be a little bit of a problem, okay, is right here. So if I drew a line right here, but I'm safe, right? It actually only touches in the solid and it's open here. So it would pass a vertical line test. So it's a function. That's how easy this is.
You're just deciding the function?
No, they are. They're called piecewise functions. They're all functions. I was just talking about it. Yeah. All right, so let's go to number 2. Same thing. We're going to graph this piecewise function. Okay, so look at the restrictions. I want x to be less than 2. Okay, here's 2 on my mark. I'm just going to put a little mark right there. There's 2. So that means that I'm only going to be allowed this way. You see what I'm talking about? I'm only going to be allowed from here over. Am I actually going to be allowed at 2? No. So let's just graph this for a second. -5 is, well, it's actually can be colored in. And then you're going to go up 5 to the right 1. Because it's a point.
I didn't know.
The only time you aren't going to come, I'll show you. That's a hard question to ask right now. I'll answer your question. Okay, so now you have your line, so draw your line for me. Okay, and some of you may be able to see this already, but I'm just going to draw it just to talk about it for a second. So here it is. This line I just drew represents 5x minus 5. but I have a restriction, and my restriction says that I'm only allowed to be less than 2. Well, here's my 2 mark. Okay, and in other words, this line right here represents 2, right? You don't need to draw this line, I'm just trying to talk to you about it. This line represents 2. I'm only allowed to be on which side of that line?
Left.
To the left. Am I allowed to touch that line?
No.
No, and that's what I'm talking about with open versus closed circles. I'm not allowed to touch that line because this tells me I'm not allowed to. So at 2, which would be on this line somewhere, you should open the circle. That's why I was telling you need a pencil. Okay, and anything to the right of that, we're going to erase. And I'm now going to erase the line. I was just using the line to talk to you about it.
You can be anywhere on the line, doesn't necessarily have to be vertical. But as long as it has to. Like,
I don't know. I don't understand the question. Keep going, let me do more. Okay, now then let's graph this one. This line says start at 7 and have a slope of -1. So I'm going to start at 7. And a slope of -1 leads me here. And that's interesting because look what happens. It falls in my open circle, doesn't it? Does it fall in the open circle when you graph it? Absolutely. Okay, so here's your line. You can go ahead and map it if you want. And let's think about the restriction. The restriction says, wait a second, I'm allowed to be at 2 and everything bigger. Okay, I'm just gonna, for simplicity for a second, I'm gonna draw a line. This highlighted line is 2. Okay, you don't actually draw that, I'm just so you can see it for right now. So the line I just drew is allowed to be on my highlighted line, which means on 2, and everywhere bigger, correct? So which side of the line do I need to erase, the left or the right?
the left.
The left. Okay, so I'm going to erase that. Some of you may just not have even drawn it. Okay, and then notice that when I was on the top line, it was an open circle, and when I was on the second line, it's a closed circle. And some of you may even want to number the lines. This was line 1, and this was line 2. In case you mess up, you'll know where. Okay, so, and that's my answer. Now, if you think about it, when I'm trying to decide on if this is a function or not, well, I know it is a function. But right here, I'm going to cross this point, and it's safe because on line 1, it's open, and on line 2, it's closed. So is it actually closed in both? No, so it's safe. There's actually only 1 point here. Okay. All right, let's go to the next one. Number 3. Okay, how would you graph this? -2x. Where do you start at, guys? 0. Okay, so there you go. And then your slope is -2, 1. So down 2, right 1. And so forth. Here's your line. Okay, and this time your window is a little different. Instead of saying x is greater than or x is less than or whatever, it gives you a window of information, doesn't it? What's your window? Yeah, it's only allowed between -2 and 3. Now, am I closed at -2 and 3 or am I open at -2 and 3? You guys got it. Yeah, it's closed. And y'all are saying that. Why? Because what can we see right here? Correct. So here, look at me if you still don't understand. Here's the x-axis. Here's -2, and here's 3. I just kind of put a little hash mark there to kind of so I can think about it. I'm only allowed between those 2 hash marks. So I'm going to erase everything else. My eraser's going to be gone by the end of the day. I'm only allowed between those 2 lines, and the circles are closed at those 2 lines. You'll see it? Okay, So now then we're gonna graph x. Well, that's easy. It's just y equals x. So 1, 1, 2, 2, 3, 3, and so forth. And look, if you don't want to draw the line now at this point, you don't actually have to. You can, once you start doing more and more of them, you'll be able to see. I want x to be greater than 3, right? So here's my little mark at 3. So I'm gonna go up here. There's 3, I'm gonna go up at 3. And what am I gonna put right there, an open circle or a closed?
Open.
So I'm gonna have an open circle there. Now what number's bigger, so I'm going to go which way?
Right.
To the right. That's line 2. And then I can erase everything else to clean it up. See it?
This is easy.
Yes.
It doesn't get harder? Oh.
Okay, not much harder. Please, jump the gun. Okay, now let's go to the next one. Y equals x squared, right? Y equals x squared means you don't know how to graph that. Make yourself a table. Okay, if x equals 0, then x squared would be what? Right? 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. This should be enough. Okay, so if you graph that, 0, 0, 1, negative 1, right? 2, 4, and so forth. So there's your parabola. I'm not going to even draw the parabola in necessarily until I find out some information about it. What do I know? I want x to be what? Greater than 0. So at 0, here's my little hash mark at 0. Which side am I going to use? Right or left? The right. But is 0 closed or open?
That's open.
0 needs to be open. Make it really big and open so it's easy to tell. So there's no question. You don't want to lose points because I couldn't tell if it was open or closed. Now then let's graph the second one. It's written backwards. Y'all aren't really used to it being written like that, so change it up. Negative x plus 3 if you like that better. So where am I going to start at? 3. And my slope is what? Negative 1. I'm not even going to go to the right. I know I can't. There's already graph there. And it tells me x has to be greater than 0. So on 0, I'm going to be colored in. And which direction am I? What did I say? Oh, I apologize. X has to be less than 0. Okay?
Yes.
So less than 0 is to the left. Sorry.
That's
You see it now? Okay. So the next one, number 5, is a triple. Let's try it. The first one is negative 1, and then up 3 over 1. And as I graph it, I can kind of glance over here and say, okay, I want numbers less than negative 2. I want numbers less than negative 2. So if you want, you can come over here and put a mark on negative 2. There's negative 2. In other words, I want everything to, if you're going to draw a line on your picture, if you went ahead and drew the whole line, you're going to have to erase. I'm only allowed left of this hash mark, right? X is less than negative 2. So all the stuff to the right of the hash mark, or the right of 2, you have to erase. And is it an open circle or closed circle at negative 2?
open.
Open. Don't forget each piece of the part. So that's the first line. Okay, the next one. Just plain old y equals 3. How do you graph plain old y equals 3?
Go up there.
Good, you go to 3 and draw a line, right? So here's 3, and you're gonna have a line here. Use your hash marks. Your hash marks are between negative 2 and 2, right? Between negative 2 and 2. So my line is only allowed between those 2 hash marks. So on the left of it, I'm going to erase, which is the left of -2. And to the right, I'm going to erase. To the right of 2. Are they open and closed at the endpoints? Closed. And look, guys, look at this for just a second. See how on -2 I'm only closed in one spot? I have a piece of a function down here and I have a piece of a function here. But on x equals -2, I'm actually only closed right here. Okay, the last one. This time I want everything bigger than 2. I'm going to grab this line, I want everything to the right of 2. So start at 3. Okay, and I'm going to go down 2/1. All right, I want everybody to look at me because this is where kids have trouble. Okay, watch for a second. This is the line I just drew. And this is where you guys mess up at. It seems easy. Okay, but this is the line I just drew. It says I want x to be greater than 2. Okay, kids tend to then start at 3. And that's not accurate. Do you see what I'm saying? If I'm allowed to be greater than 2, I'm allowed at 2.1 and 2.2 and so forth, right? So that's why I have this hash mark here. I'm allowed on that hash mark. I'm either open or closed. Don't erase. So here's your imaginary line here. Okay? Here's the imaginary line. Listen to me. So if I drew this line, and this is the line I just drew, if I'm saying x is greater than 2, it doesn't mean start my line here at 3. No, it means go to 2 and put what kind of circle?
Open.
An open circle at 2, and then start it at 2. Kids want to erase and start it at 3, and that's not right. Do you see what kids want to, what you guys tend to try to do? You try to say, okay, bigger than 2, so at 3 I'm gonna start erasing. No, go to 2. It needs to be open or closed at 2 from 2 on, not past 2. Okay, number 6, last one. All right, the problem here says 2x plus 7. And now that you've kind of gotten better at it, should I build my line to the right or to the left? Left, because it says less than -4. -4 is out here. Here's -4.
Bless you.
Okay, everybody, if you're so confused, look up here for a second again. Watch. I'm telling you x can be equal to or less than -4. So I go to -4, which is right here. I decide if -4 should be open or closed. What should it be?
It should be closed.
Closed. Then I do what it tells me, which is less than. You always go to where it tells you. Don't skip to the next number. So that's the first line. Now let's go to the next line. Negative x. Well, y equals x is just 1, 1, 2, 2. Y equals negative x is the other direction. It's this line. And I'm in a window again. What window am I in? Between what two numbers? -4 and 1. So here's -4, and here's 1. Guys, that means I'm actually, be careful. If you draw this line, at -4, where should I be? Here's -4. I should be at -4, and I am. So go up to -4, and what should I be, open or closed?
Open.
Open. You have to be at -4. Then I go all the way to 1. You have to be at 1. At 1, am I open or closed? You look right here. closed. You have to be at both of those spots. The last one. Start at -2, and your slope is 1/2. So up 1 over 2. This is your line. Okay, it tells me x is greater than 1. So when I go to 1, and you can use a highlighted thing again here to show you. I'm not actually on a direct point, am I? No, it doesn't matter. So what? So the highlighted section at 1, wherever you are, it tells me to be open. So I want an open circle right there. And I'm going to erase everything to the left. Okay, and you're done with your notes.